Somebody had requested that I make a video regarding the Baofeng handheld transceiver, and I realized I don't have one here. I think they're all up north. And I don't even have the images regarding. However, I have this one image, so I figured, well, I'll make a little video more on kind of radio direction finding, um, and just start off with using what I had used for my first fox hunt. And this is basically a Nido dry milk, powdered milk can. That the lid, I cut a circle out of 325 mesh stainless steel screen. It's used for silk screening. And that basically made a uniform metal Faraday cage that I added some shop towels, or paper towels, to cushion the Baofeng, that the antenna was removed. And when I got closer, I actually set the frequency to the third harmonic. So I was operating, or actually receiving, excuse me, I wasn't transmitting at all, receiving at the 400 megahertz range versus the 100 megahertz range of the transmitter, the Fox. So I just figured I'd show that. That's the only picture I could find digging through everything. I don't really have anything else regarding the Baofeng. What I'll try to do is when I get to it next, I'll try to do a little video on probably interfacing with the cable and changing settings and maybe some basic operation. But this will be a start to get me going so I don't forget. But I'm going to segue over to this Fledermaus detector. I'm not even going to try sounding German. Bat Detector, basically, in VLF receiver. And what this is basically
Überrascht,
interesting device where a
was da
gentleman
rauskam, und habe hier
connected a
tatsächlich auch eine
BNC
BNC-Buchse
connector.
angebaut, damit ich da eine Antenne anschließen kann.
And so
Und
he
ich habe ja hier
connects
so meine
this
kleine
loop antenna.
Mini-VLF-Antenne, das sind 100 Meter Kupferdraht.
Very nice.
Ich mache mal ein bisschen mehr Beleuchtung hier. Und
And I'll go back to where I was here. Nope, that's not the one. That's a little higher energy. Technically, that is a directional antenna, but that's not the one. Where did I go? Here we go. Okay, so let's get these viewed. Let's just do it full screen, I guess. Can I do that? Oh, it's not going to work for me. Oh, how do I go back? Let's see, back that way? Yeah, there we go. So this is kind of the idea. This would be a way larger, way more sensitive, and a different frequency design. But it's, again, a loop antenna. Kind of not, here we go. I guess we'll go here. This is interesting, another style. This is a World War One skier. I want to say like a Scandinavian country. I forget exactly. But this is radio direction finding. I'll do some historical photos, I guess. This is a Vietnam era. This is a U.S. Army radio direction finding little position. This is World War One. Also, not sure exactly who designed. Oh, you don't like to. There we go here. Which direction's gonna show me? Well, anyhow, I guess it's just going this way. This is a wire I salvaged. These come from the CRTs, and I already unwound one of the, I think the other side here, of the electron beam, electron gun controls, basically to steer the beam, if I understand correctly. I think that's correct. And then this is coil, I think, what do they call it, like a degaussing coil or something like this? I don't quite exactly understand, but that's another source of some free, cost-effective magnet wire that can be used for the loop antenna. This is a BNC connector that I salvaged off a old broadcast station from GVSU at the surplus store. I picked up for a couple bucks, non-functioning VHS player. So I wound up making it. Actually, I started working on the mini Bat Detector first before I found this Franzis website. The YouTube channel, and then a website I'm going to show you also in a second. So I had already started working on thinking, okay, I should be able to interface a circuit where there's a transducer right here of the Mini-3 Bat Detector and just use an antenna, and probably some sort of network, matching design to make sure the circuit inputs for the antenna is matched to the correct, say, impedance like ohms, um, and power maybe too. You don't want to overload that input of matching to the transducer. Output or input into the circuit. I wound up cutting this rod, so that's not correct. I mean, it's a correct hole, correct position to fit, but actually I had to bring the connector down lower because the board's in the way. Some photos there when I was working on. Get some shots. They didn't have a schematic, but the company that makes this was kind enough to provide a schematic when I asked. Let's see, so some of the wires coming out. Transducer. Let's see here. Oh, there's another World War. This is a World War II. I think this is SS, radio direction finding. Okay, here we go. This is where the position wound up going for the BNC input. And I'm thinking I'm going to do another input. I'm not 100% sure for the MEMS detector. And I'll segue into that next. Let's see. So the Fledermaus detector kit, I figured when I saw the video, I'm like, oh, neato. I'm just going to go ahead and buy one of those. And I found somebody, I think it was in Marquette, had, this is a U.S. Army RDF. Oh, and this is a modern day National Radio Astronomy Observatory. I was about to say National Reconnaissance Office, but I think it's the National Radio Astronomy Observatory patrol truck. This is I think it's like NSA Army here. Okay, let's get this closed out. Here, back to here, and I had emailed Franzis, and they're really good about connecting me actually with who works with the device, and then sending me schematic information also regarding that's the capacitor or the condensators marked capacitor in the diagram. And what they have is a link they sent here that shows how to basically change the frequency. So the frequency determining capacitor is shown in the schematic they sent me, has the 1 nanofarad capacitor. And this means the lowest frequency is around 20 kilohertz, but you can receive lower frequencies actually. So that's if I wanted to go lower frequency. However, I want to go higher frequency, and they note here, and this is actually a Google translation, this is a German site, but you can use an electric or a MEMS microphone. So I purchased another transducer and a MEMS that Dodotronics had suggested were the best ones on the market, and there's a intelligent Bat Detector instructable that details, and if you look down in the comments you can see where I was commenting back and forth, and the gentleman from Dodotronics, I think the proprietor actually and the developer, noted which transducer and which MEMS to purchase or recommended, and I wound up purchasing those. So I have those, and I'm going to wind up doing this type mod with, I think I'm going to try the Franzis first so I'm comfortable, and then I'll do that next with the Mini-3 Bat Detector. So then I've also wondered about taking and modifying the tuning capacitor and turning that into a digital sweep, so I could have that. I don't know if the response rate would be fast enough, what the circuitry latency will be, but I wonder if I can get what the fastest sweep I could get, so I could get more of a persistent type, real kind of more of a real-time signal analyzer, spectrum analyzer output potential. So basically I can take the output of the device and then input that into, I guess I could have a little standalone screen or put it into a computer and then have, where like maybe using Spectrum Lab or some other software, I could see a full range, a full bandwidth signal to observe. I don't know, those are some of the interesting radio direction finding, fox hunting things I originally invested in the Baofeng for outside of emergency communications and maybe transmitting with, but the more I read into it, it's not the best transmitter without doing some bandpass filtering. So basically, whatever you want to transmit, frequency you want to transmit on, you're only transmitting that band, so there's no odd harmonics and noise or frequencies going out that are not legally authorized to be, or at least good etiquette to have transmitting. And also, there's the other range of frequencies, and that's down to the ultrasonic signals. And with detecting with a transducer, or MEMS, the phonons, the pressure waves. And technically with a circuit, you should be able to, and you can, with a loop antenna, and also detect the electromagnetic signals, or the photons, they say. So, this is the update for a special request. Somebody wanted me to make a video on the Baofeng. I don't have the Baofeng here, so I don't have anything really to do with it. So, but what one photo I found kind of made me think about radio direction finding and the last winter season's radio direction finding project that I need to complete the latest transducer and MEMS upgrades, as well as work on some loop antenna designs, or at least loop antennas. So, or at least a loop antenna for this season. That's about all I can think of. Take care, be safe, stay healthy, and until next time.